everybody, welcome to 9.9 Day 2, more of linear, quadratic, and exponential models. So today we're going to put together the equation, key features, and a quick sketch of a graph. So let's do a little review. Linear model, the equation is y equals mx plus b. And the key features are that m is the slope, and b is the y-intercept. And then you would also have to note if it's increasing or decreasing. Increasing is if the slope is positive, and decreasing is if the slope is negative. And then the new thing today is, given a word problem, can you sketch a graph of the function? So what we'd want you to do is draw an x and y axis, and we would want you to label both of them with the appropriate unit of the problem. And then you would need to show the y-intercept wherever it would be on that axis, and then just show if the line is increasing or decreasing. Just a real quick sketch. All right, on to exponential. Exponential model is y equals a times b to the x power. A lot of times in word problems, you're given a rate as a percent. And if that's the case, you're going to use y equals a times 1 plus or minus r to the t power. And then r, you would convert the percent into a decimal. We did those a while back. The plus would be if it's a growth, and the minus would be if it's a decay. And key features would be telling me if it's a growth or a decay, and then also saying if the curve is increasing or decreasing. And then for a quick sketch of an exponential growth or decay, you would again need the x and y axis. You would have to label both of them with the units of the problem. You would need to graph the a, which is the initial amount, the intercept. And then you would just have to draw a curve, either increasing or decreasing. So this would be a growth, so it would be, actually I don't know. A growth would be going up, and a decay would be going down. So actually, let's do both. This would be a growth. If it was a decay, it would be heading down like that. All right, and then lastly, the quadratic models, recall, is y equals ax squared plus bx plus c. Now, in the context of word problems, it's usually, if it's a falling object, it's going to be y equals negative 16 t squared plus initial velocity times t plus initial height. Okay, so negative 16 is the gravity, that's a. V sub 0 is the initial velocity, that's b. And then h sub 0 is your c, which is the y-intercept, the starting value. And then the key features on the graph, all we need is if the vertex is a max or a min. You don't have to worry about anything else for these graphs. All right, same thing. When you graph these, we're going to have two axes, the x and y, and you're going to label them both. And then you're going to need the starting value c, wherever that is. And then you're just going to have to show if it's the vertex is a max or a min. So, for example, if it was a max, it would be going up like that. And if it was a min, it would be going down like that. Okay, but let's try some so you actually know, given a word problem. So we're going to do one of each. So number one, first you have to tell what kind of model is it. So read number one and let's figure out what type it is. The cost to rent a car is a flat fee of $50 plus, that's good, plus an additional 20 cents per mile driven. So because you're adding a constant amount, this is going to be a linear model. Okay, and then we need to write the equation, y equals mx plus b. So what's what here? So y equals mx plus b. The starting amount is the $50, and the additional, that's going to be your slope, so 0.20x. So that's your equation. And then we need to sketch a graph. So we have to label the axes here. So the x-axis is going to be the number of miles driven. That's the independent variable. And then the y-axis is going to be cost or money. Okay, so we're going to start this graph at 50. So you're going to make a dot at 50. And then very simply, you just have to show, is the line increasing or decreasing? And because the slope is positive, the line will be increasing. So that's what you would need for a linear graph. All right, number two. A rocket is fired into the air from the ground level with initial velocity of 50 feet per second. What type of model is this? So rockets, they're going to go up and then come down. So that's going to be a quadratic model. All right, the equation. So when they have the initial velocity equation, we're going to use this one. Y equals negative 16t squared plus v0t plus h sub 0. And let's talk about what everything is. Initial velocity they give us is 50. And initial height, since it's starting at the ground, that means the initial height is going to be 0. Okay, so if we plug those in, y equals negative 16t squared plus 50t plus 0. And you don't have to put the plus 0, but that's our equation of the quadratic. And then for a quick graph, we're going to have to label the axes. The x-axis is going to be time in seconds, and the y-axis is going to be feet. All right, we need the starting value, which is 0. And then you just need to show, is it going up first or down first? And because the rocket is fired into the air, you're going to go up and then coming back down. And that's all you need for that. So in this one, the vertex would be a max. Okay, lastly, you deposit $200 and it earns a 5% interest. Whenever there's a percent rate, it's going to be exponential. All right, the equation. It's y equals, because there's a rate, it's going to be this one, a times 1 plus or minus r to the t power. Let's see. A is the starting amount, so 200. And R is the percent as a decimal, so 5% as a decimal is 0.05. That's R. So let's plug all that in. The equation is y equals 200. Because you're earning interest, it's going to be 1 plus 0.05 to the t power. That's our equation. And then we need to do a quick sketch of the graph. So x and y axis labeled. The x axis here is going to be time in years. And the y axis is going to be the money earned. All right, we need our y-intercept. Our initial starting amount is up at 200. And then the question is, are we growing or are we decaying? And because we're earning money, we are growing exponentially. So you would just need to do something like that. All right, guys, nice job. I know this one was kind of long, but we're going to review it tomorrow in class. Thanks for watching.